Now here we will talk about partial fractions, also called partial fraction decomposition. Okay? We cannot find the antiderivative in a traditional sense in a problem like this because it's raised to the -1. If we remember the antiderivative rules, we can't find the antiderivative when n was equal to -1. So what we need to do is break it down into partial fractions. Now, we are going to say 1. This is going to have 2 parts, remember. This is a over x minus 4 plus b over x minus 2. How do we get that? We just factor the denominator. Now, what we need to do is cross multiply. Plus b times x minus 4. We cross multiply right here. Now, this is the thing that we need to do. We need to find the zeros of the function. What would give us a 0 in this denominator? That would be x is equal to 4. So we're going to have a case where x is equal to 4 and also a case where x is equal to 2. When x is equal to 4, we have 1 is equal to a times 4 minus 2 plus b times 4 minus 4. This crosses out. 1 is equal to 2a, so 1/2 is equal to a. On this other side, we have the other occurrence where x is equal to 2. We repeat the process. A times 2 minus 2, that cancels. 1 is equal to -2a, so it follows that a. Now, oh, I'm sorry, this is b. I'm sorry, this is b. Of course, because the a is canceled out. Now, this problem is not finished. We have found that 1/2 is equal to a and -1/2 is equal to b. This is not finished. Remember, we have to put this back in. So we come back up, kind of out of order here. We're going to say 1/2 over a plus b over x minus 2. That's -1/2. I'm sorry. X minus 4 over x minus 2. I'm sorry. So that's our a over x minus 4. That's our b, which is -1/2 over x minus 2. But we can't leave that, so we have to go back to our old natural log rules. If you remember, the antiderivative of 1 over x was natural log of x plus c. So we simply say natural log minus 1/2 natural log x minus 2 plus c. That's our final answer here.